So we titled page 20, Adding and Subtracting Rational Number Word Problems, okay? So today we're going to do the same thing kind of like what we did on with our integer word problems, okay? So for example, there was a lot of where we wrote question 1 and all the keywords, and then from there we kind of worked out our problem. So you want to listen and see how we're going to be setting up and breaking down these problems. We'll do that for the first half of class, and second half of class we'll kind of go in depth with working on your exit ticket with analyzing some word problems. Okay? So we're going to start with number 1, and we're going to look for keywords in our first question. Any volunteers, you can click the raise your hand feature to read our first problem for us. Okay? Alrighty. Miss Tolene, go ahead and read our word problem for us, please.
1 word. Julia collected 8 4/10 gallons of rainwater. That month she used 5 2/10 gallons of rainwater to water her garden, and 1.5 gallons of rainwater to water the flowers. How much rainwater is remaining at the end of the month?
Awesome, and thank you for saying it correctly, right? 8 4/10, 5 2/10. Y'all gotta get into that habit. Absolutely. All right, Jolene, so what are some of the numbers you noticed, and what are some maybe keywords you noticed with those numbers?
It would be remaining.
Okay, so remaining is kind of helping us to solve that at the end, okay? So let's kind of, so that's correct. All right, let's start from the beginning though. What's the first number that we noticed in there?
8 4/10.
Right, 8 4/10, and that she collected that amount. So that's going to kind of help us understand that that is our starting number, 8 4/10. So Tolene, if I'm starting with that amount, would that be a positive or a negative number? What do you think? Like if I have that amount of gallons.
Well, it would be positive because collected is not negative.
Right? Awesome. I'm not losing 8 4/10 gallons. It says we have 8 4/10 gallons. So we're going to keep it as a positive number. Awesome. Alrighty. Tolene, let's keep it going, okay? Let's do the next one. What's the next number I noticed, and is there any keywords attached to that number?
It's the next number with the keyword is 5 2/10 because there's used, which would make it negative.
Awesome. So we used 5 2/10, and we used 1 5/10, right? Absolutely. I went ahead a little bit of you. Sorry about that. But that's good to know. We used 5 2/10 gallons. So that's a negative number, right? Because it's decreasing in that amount. I'm not gaining 5 2/10 gallons. I'm losing that amount. I'm also using 1 5/10 gallons. So again, I'm losing that amount. Okay, Maya, you got a question?
No, I just wanted to watch it.
Okay. You can do the next one. Okay, no worries. Alright. So we use 5 2/10, we use 1 5/10, and we have altogether 8 4/10. And Tolene kind of mentioned a little bit earlier about noticing that kind of keyword, the remaining amount. Okay, so Tolene, what's kind of your thought process in solving this problem? Because I will tell you right now, guys, there are multiple ways you can solve this problem. But Tolene, what was the way that you thought to solve it?
Well, on every one of my thought processes, I would gather the numbers and subtract and see how much water.
Awesome. And that definitely can work, right? That's absolutely a possible way. So for example, Tolene is saying I can collect and add 5 2/10 or 5 2/10 and 1 5/10 and then subtract it from 8 4/10. Absolutely. You would get the right answer. Now for this type of problem, there are multiple ways you could do it. Okay? So I'm going to show you kind of two ways. One echoes the way that Tolene mentioned, and one is another way to think about it with our positive and negative numbers. So for example, I'm going to go with the first way that Tolene mentioned. Now this isn't exactly how she said that she would do it, but it's the same thought process. So one thing to keep in mind is, yes, there are multiple ways you could do it, right? There's not just one way. So Talene said we would take the 8 4/10, and then we're going to take away the 5 2/10 and the 1 5/10. Now, I'm going to add these as negative numbers. Now, when I add them as negative numbers, that's going to be taken away from 8 4/10, because remember, different signs, I have to subtract the two numbers. So I wouldn't get the same answer, I get a different answer instead. Alright, Rita, you got a question? What's up?
I've got 2 questions.
Okay. Alright, so let's kind of break down this problem, right? So we have a good understanding of how to get our answer and what we need to do. So, Talene, again, you're my lucky volunteer, Talene. I promise I'm going to help you through it. When I look at 8 4/10 plus negative 5 2/10, I know it's a little bit different than maybe what you said to do. Your method's still correct. But, Talene, what would I do when I have 8 4/10 plus negative 5 2/10? Could I add it like normal, or do I have to subtract the two numbers?
Well, you just basically do the same way of adding a positive number to a negative number. You're just taking how much. It's like subtracting.
It's like subtracting, right? Because I have a positive and negative, they don't mix together, right? They start canceling each other out. So I'm going to go ahead and work this out to the side. 8 4/10 minus 5 2/10. So if you're wondering how I'm doing subtraction with an addition problem, go back to your notes, right? Adding different signs means I need to subtract the two numbers. 4 minus 2 will get me 2. Bring down your decimal. 8 minus 5 will get me 3. We have more positives, so my answer is positive 3 2/10 plus negative 1 5/10. Okay. Jaden, you got a question? What's up? Say again?
It was still up from earlier.
Oh, okay, no worries. Alright, then we need to go ahead and solve it. Okay, so we need to go ahead and do the last part. So 3 2/10 plus negative 1 5/10. Again, we're going to add those up. And just like Talene mentioned, I can't add like normal. They're different signs. So I have to subtract the two problems. So when I subtract the two of them, that's still like subtracting 1 5/10. Two minus 1 gives me 1. Decimal goes there. So my answer, when they ask how many gallons are remaining, it'd be 1 7/10 gallons. That's what my final answer would be. Now notice, we were used to writing with those integer word problems like, oh, this means to add, this means to subtract. But this problem, I got more than one operation, right? So for example, the way that Talene said it, you could do it the exact same way and get the same answer. I could have done 5 2/10 plus 1 5/10 and then subtracted it. That's definitely you get the same answer. It's not wrong, it's just another way to think about it, right? And I want y'all to see that there is more than one way. There's not just one way to solve it. Either way, you're still taking away, whether you add a negative, or like method 2 would be just to subtract all the way through. If I did 8 4/10 minus 5 2/10 minus 1 5/10. 8 4/10 minus 5 2/10, we saw that it was 3 2/10. 3 2/10 minus 1 5/10 gets us the same answer of 1 7/10 gallons. So do I care which way you do it? No, I don't care. You can do whichever way you want. Okay? But the most important thing to do is make sure you understand what they're asking for in that problem. Okay? So you could go back and forth with our signs and operations, but understanding how to do each of those is what's important. Okay? Questions? No questions? Good alive breathing? Not too bad, right guys? Right? Not too bad. Not too crazy. Now I'm looking at your cameras to see if I need to move on or I need to slow down. So if you don't have your camera on, I'm moving ahead of you. Ooh, there's something else. Now again, you have to make sure you're keeping up with your notes. If you come next week face to face and you don't have any notes, we are going to have a long discussion. But if you are staying online, guess what? You're still going to have a long discussion because you got to make sure you're keeping up with all the lessons we're doing. Okay, so use your notes, do the activity. That's how you move forward. So important. Okay, let's keep on moving. Ms. Myra, oh, well, before Myra does that, let's kind of break down this problem again. Same routine, and they worked it out the exact same way. All right, this is our method 1 of doing the problem. Now again, Tulene said another way, and her way is correct. I showed you another method, that way is correct. Do whichever one makes more sense to you. Whatever doesn't make sense, skip that. Right? Don't try to force yourself to do it one way. Do it in the way that it makes sense to you. All right. Ms. Meyer, let's do the next question. Go ahead and read that for us, please.
At noon in Alaska, the temperature outside was minus 12
and 3/5
and 3/5 Fahrenheit. During the next 4 hours, the temperature decreases 7.5 Fahrenheit. What's the final temperature at 4 p.m.?
Awesome. So I'm going to write number 2 and look for my key words, okay? So Ms. Meyer, what are some of the numbers you noticed and the key words with those numbers?
Minus 12 and 3/5.
Okay. And so what is negative 12 and 3/5? What is that?
It's a fraction.
It's a fraction, but what is that number representing?
The 12 and 6/10.
Okay. So what is that number representing, Maya? Read the words right before that. Don't overthink it, okay? What is that? Is that the temperature when the day is done, when it's starting? What does it represent?
At noon, the temperature outside.
Awesome. So I can even think about it as my starting temperature. So we're starting at negative 12 and 3/5 degrees Fahrenheit. That's my starting temperature, right? And that's very cold in case some of y'all didn't know that, right? Like I'm complaining about how cold it is outside this morning, but that's a whole nother level, guys. That's a lot. Alright, so it's starting at negative 12 and 3/5. And I like that Myra also mentioned, hey, Mr. Dan, that's like negative 12 and 6/10. Yes, you could write it as a decimal. That's okay. Now, only thing I would do is, usually if they give you both numbers as a fraction, you have to give your answer as a fraction. But if they gave you answer choices as decimals, Myra, you could definitely put that as a decimal. Up to you. Okay, Myra, what else do you notice?
The temperature decreases 7.5.
Right? Awesome, it decreases. So, Myra, what do you think that word decreases mean? Is it positive or negative? What do you think?
Negative.
Awesome. So if it decreases 7.5, that's like a negative. Or I could even just subtract it, right? It's up to you. I wouldn't subtract a negative. You can either add a negative or just subtract that number as what it is. I'll show you what I mean in just a second. But notice how Myra found that key word. Ooh, it decreases by that amount. We're starting at noon at negative 12 and 3/5. Those are all the kind of key things you want to keep up with, right? Does that make sense? How does that look like? Things like that. So Myra, how would you solve this problem? What would you do, Myra, to solve this?
So, I would...
There's more than one way, so don't worry if it's different or maybe another way than I was thinking.
So, I would just subtract 7.5 from 12 and 3/5. Yeah. And, like, more the way I would do before, I would just turn both of them into a decimal.
Okay.
It's a long thing, and then I would find the answer and then turn it back to a fraction.
Okay, so you would do negative 12 and 3/5 minus 7.5? Is that what you are saying?
Yeah. Yeah, or plus minus
right? And I can do either way because either way is correct. I'm going to do it the first way you told me, Myra. So I'm going to go with method 1, and I'm going to do it the way Myra said. And that's a correct way. There's other ways you could do it, but that's a correct way to do it also. She said she's going to take negative 12 and 3/5 and subtract 7.5. And that's okay, right? I can totally do it that way, no problem. The other method, Myra said, was to take those same fractions, negative 12 and 3/5, but add negative 7.5. Both of those would be correct. If you solved either one of those problems, you get the exact same answer if you follow your steps. Now, if I ask you for just the expression, hey, give me just the problem, you could give me either one of those and I'll give you full credit. Because it's both the same thing. I'm both decreasing by 7.5. Subtracting 7.5 is decreasing. Adding negative 7.5 is decreasing. It doesn't matter which way you do it. It's whichever works for you. If you like one way more than another, hey, go for it. Right? But again, it's totally up to you how you want to work it out. Okay? So Myra, which way do you want to work it out? Do you want to use method 1 or method 2?
Any is okay.
Okay, thank you for helping me narrow it down. Okay, but another way to think about it, guys, if I were to do method 1, okay, my rule for subtracting integers or even rational numbers, keep the first one the same, change it to addition, and Myra, what's the opposite of positive 7.5?
Negative 7.5?
Yeah. So Myra, let's look, are these two the same expressions?
No. Yeah.
They are, right? Negative 12 and 3/5 plus negative 7.5, negative 12 and 3/5 plus negative 7.5. Right? Those are both the same expression. Excuse me. So if you notice, either way, I end up doing the same problem. So they're both negative, so I can add like normal. So I have 12 and 3/5 plus 7.5. So I gotta find a common denominator with those, right? Mari, do you know what our common denominator could be with those two fractions? Or you're not sure?
I'll see.
I know y'all are writing also. 10, right? If I do 5 times 2 to get 10, well, I can do 3 times 2 and get 6. Because now I get a common denominator between the two. Because you always want to try and get a common denominator. It's always one of our goals. Now here's the thing. If you forgot how to get common denominator, Mr. Daniel got you. Go look at the last two, not last week's asynchronous, but the week before's asynchronous activity. That will help you out. If you are still not sure, go look up on YouTube, hey, how to find a common denominator. I swear, you go type that in YouTube, it sounds crazy, you will find a video to do that. Okay, so make sure you take care of that. Same sign means I can add it like normal. Negative 12 plus negative 7 will get me negative 19. 6 plus 5 will get me 11 tenths. Now, Myra, what's wrong with 11 over 10? What's wrong if I just leave it as 11 over 10?
It's not a fraction. It's improper.
There you go. It's improper, right? So 11 tenths, what I could do, well, that's like one whole. Think about it this way.
You have to subtract 11 out of 10. I mean 10 out of 11.
Right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, that's 10 out of 10 shaded. I need an extra 1 to shade it. So this whole thing is like 1, and then I have 1/10 left over. So that 11 tenths is like negative 1 and 1/10. So I got to add it on over. So I get negative 20, and I'll have my 1/10 left over. Now if you did this method 2, guess what? You get the same answer, right? But it's up to you what you want to work out. If you want to do it that way, you're more than welcome to. Whatever works for you method-wise. Okay. Anya, question, what's up? You can unmute.
You have to add the negative 1 and 1/10 to the negative 19 and 11/10.
Technically, we're just adding that negative 1 because this is 11/10, right? 11/10 is one whole. They'll have 1/10 left over. So that's where this 1/10 is left over. But then we add that negative 1 to the whole number to our mixed number. Okay? Great question. Aman, what's up?
I was just wondering if I could save the next problem.
No worries, team. You can definitely do that. Sounds great, Aman. Awesome. So let's go ahead and look at that on the PowerPoint again. So just in case we missed any of the notes. They did the same thing. They chose to subtract it. If you want to add negative, you're more than welcome to. It doesn't matter. Your thought process is correct. Now what they did is they found their common denominators, just like we did. And when we add this up, remember we get 11/10, so we have to add that 1 over. So the temperature at 4 p.m. is negative 20 and 1/10. And guess what? That's the answer we got. Okay? Alright, bear with me, okay? I'm going to do one more question, one more word problem. I'll give you a break, and then we'll do our exit ticket, okay? So I'm going to steal some of the break time, but the next question is kind of quick. Alright, Aman, go ahead and read that for us, team.
During the hottest week of summer, the water level of the Muskrat River was 5-6 foot below normal. The following week, the level was one third of a foot below normal. What is the overall change in the water level?
Awesome. So normal, or average, you can kind of think about it as 0, right? So Iman, what's the first number we noticed, and what's any keywords attached to it?
5-6.
5-6. And what about 5-6? There's any keywords that I can attach? It was, right? And it was a foot below normal, right? That word below is going to be that kind of trigger word. It's good to know that it was, right? Because that's kind of like helping you know it's the starting point. It's a good thing that you pointed that out. Okay? So let's look at that one. So this will be our last one that we do. So it starts, and you can put, because you said that it was, right? So it's like my starting point. It started below normal, and that was at 5-6. Now, Amon, if it's below normal, do you think that's positive or negative?
Below normal is negative.
Right, it's going to be negative. Right, so think about normal as like 0, right? If it's below that, it's negative, right? It's not at the right point. And we know it's the starting one because just like Amon said, it was there first. Alright. Amon, what's the next number and keyword that I noticed?
The level was 1 1/3 foot below normal.
Right? And so that's the following week. So it's kind of the change I'm noticing. Excuse me. And if it's below normal, what do we say that would be, Amon? Positive or negative?
Negative.
Perfect. Alright, so now there's one more keyword. What's our last kind of keyword we might notice in here, Amon? Maybe to kind of help us understand what type of problem we need to do.
What is the overall change in the water level?
Awesome, because we're looking for the change, okay? if you're looking for the change means kind of the distance between those two numbers on a number line, right? How am I going from negative 5, 6 all the way to negative 1/3, right? So you can think about that as distance on a number line. Or you can think about it as the word difference. Now we talked about difference and the distance on a number. We talked about that. Old news, okay? So when I think about that change, remember that's the bigger number minus the smaller number. Okay. So think about the bigger number minus the smaller number. So I have a negative 5, 6 and a negative 1/3. So Iman, what would I do for my bigger number minus my smaller number? Now, actually, before we do that, Iman, I'm going to help you out, okay? I want to find a common denominator, okay? I want to find a common denominator, so it would be what?
Simple. The common denominator of both of them would be 6.
6. Right? Because I don't want to start comparing two fractions with different denominators, right? That's like saying, oh, if someone did 2 quizzes and got this grade on both of them, and someone did 15 quizzes and got this grade on them, your averages are going to be different, right? You want them to have the same denominator. So for 1/3, I can multiply it by 2 so I can get a common denominator of 6. And guess what? I don't have to do anything for the other one. It's already in a common denominator. So it's like negative 5, 6, and then we have our negative 2, 6. Okay, so what would be my bigger number and my smaller number in mind? Now think about negative numbers, right? So remember, sometimes when we go further on the number line,
6 is the biggest one.
2, 6 is the bigger one. Yes. Okay, 2, 6 is my bigger one on the number line. And the reason it's bigger is because it's closer to 0, right? Think about it, 0's right here. I'm trying to see how y'all look at me with the number line, okay? If 0's right here, my negative numbers are on the left side and my positive numbers are on the right side. So remember, the furthest to the left, the smaller the number, furthest to the right, the bigger the number. Negative 5, 6 is furthest to the left, so it's going to be the smaller number. So we have negative 2, 6 minus negative 5, 6. That is going to be my expression to solve it. Now in this case, there's only one way to find that. There's only one way to do the biggest number minus the smallest number. Okay? You want to find out the distance or number of spaces between those two numbers.
Wouldn't it tend to be like absolute value?
What do you mean? Like finding out the
Number of spaces.
It's kind of like finding the absolute value, right? Because whenever we look at it, it's still asking us, because distance is always positive, right? You don't go and say, hey, we want negative 12 miles to HEB, right? You don't say that, right? So it is kind of like absolute value in a sense, but solving it, you still want to use these negative numbers because that's how you can tell where it is on the number line. That's why it's important. So our rules, again, it's like the third time I'm talking about subtraction rules. Keep the first one the same. Change subtraction to addition. The opposite of the second number, negative 5, 6, is positive 5, 6. And if you want, you can cross out that old problem, up to you. Some people think it's too messy, so they don't do it. It's whatever. Now remember, different signs I can't add like normal. It's not my fairy tale ending, right? I have to do some subtraction. So I got to take the bigger absolute value minus the smaller absolute value. Now here's the thing that people are getting confused with, right? Because I'm doing multiple steps right now. Ooh, I just did a subtraction step. Oh, now I got to do my adding step. I got to do all my rules. You have to juggle between all those, guys. Go back to your notes and say, ooh, I got an addition problem. What do I need to do? Ooh, I got a subtraction problem. What do I need to do? Go back and fill that out and read it. The more you read it, the more you look at it, the better you will do with those activities. 5 minus 2 will get us 3. And we keep our denominator the same. Okay? So we keep those the same. Denominator stays the same. So 5 minus 2 is 3, so I will get the same answer here, 3/6. I have more I have more positives, so my answer is positive. But before I do that, I gotta simplify, right? Aman, what can I divide 3 and 6 by to simplify this answer?
You can divide it by 3.
Again, if you're like, Mr. Jenna, why are we dividing? Why are we simplifying? It's in your notes. It's in the asynchronous video. Okay, this one is from 2 weeks ago, so go back and watch it. It's still open. So you divide it, you should get 1/2, and it's 1/2 of a foot difference. Awesome, thank you, Iman. So, breaking it down is just like this, reading all the steps, seeing how to work it out. The more you break it down, the more it makes more sense in how to solve the problem and what to do with the problem. Okay? So let's look at that PowerPoint one more time, just to get a little more understanding. If you didn't write it down, you can see it on the PowerPoint too. So the change is what they asked us to do. So my bigger number minus my smaller number, -1/3 minus -5/6. So we keep the first one the same, change to addition, add the opposite. We found a common denominator. We get 1/2 foot. Now, if anyone's confused, this is where you can do a great opportunity to look at this number line, because most people like looking at it on a number line to make sense of it. So if I have 2/6 over here, and we have 5/6 over here, they want to know how many spaces is it from 5/6 to 2/6. So it's 1/3, 1/6, 2/6, 3/6 spaces, and that's what we got originally.